Welcome everyone to our continued discussion on data input and output. In this lecture, we're going to be focusing on HTML tables. If you really have no familiarity with HTML and you're not really using it that often, you may just want to skip this lecture since it's just going to focus on reading HTML tables from a website or HTML file and then exporting a data frame to an HTML table in case you want to display it on a website. But if you never find yourself using HTML in general, you may just want to skip and continue on. But for those of you that do use HTML, this may serve to be a very useful video. Alright, so we know websites display tabular information through the use of HTML table tags, for example the opening table tag shown there. Now Pandas has the ability to automatically convert these HTML tables into a data frame. Now some important notes before we continue to show you how to use this is not every table in a website or on a website is available through HTML tables. Sometimes websites will use a different formatting, or they're using JavaScript, or maybe they just have an image of a table, which is just like a PNG file. For certain cases, Pandas is actually not going to be able to read it, in which case you need to move on to something like Beautiful Soup for web scraping. And even then, if it's something like an image, that can be really hard to read, and you'll need specialized software to convert an image into a table. So there are a lot of limitations with what Pandas can do here. Pandas is essentially just going to read an HTML, get a list of all the table tags, and attempt to convert those into a data frame. You should also keep in mind that if you're attempting to read a URL directly from Pandas, that some websites may actually block your computer from scraping the HTML of the site through Pandas, in which case you'll have to try to figure out how to work around that, typically with a specific web scraping tool. Again, Beautiful Soup is one of the most popular web scraping tools with Python. So the last note I want to say here is often websites actually have an API to grab information from the website. So it may be a lot easier to just skip this process of reading in HTML tables and just go straight to the API. So you should always check if that's an option first. Okay, so what we're going to do is we're going to work through an example of grabbing all the tables from a Wikipedia article and then cleaning and organizing the information to get a data frame. And then we'll also show you how to output a data frame to an HTML table, which is really useful if you plan to display tables on a website. Let's get started. Okay, so here I am at the Jupyter Notebook. As a very quick note, if you've decided to not use our environment file, you may need to conda install lxml or pip install lxml, which is essentially just a library for parsing through HTML data, which Pandas is going to use on the back end to convert the HTML table to a Pandas data frame. So keep that in mind. If you're using our environment, you should be good to go though. Okay, so I've already imported Pandas as PD. Let me delete this cell. And what we're going to do is we're going to take a look at the world population Wikipedia article. And that's linked for you in the lecture notebook, or you can just Google search world population plus Wikipedia, and it should take you to this page. Keep in mind that this page is on Wikipedia, and Wikipedia can be edited. So there may be changes by the time you're viewing this world population article. However, I would imagine that even far into the future, world population article on Wikipedia will have some table on its page. And in fact, there's lots of tables on this page. There's one right here, world population, millions, or top 10 most populous. There's population by continent as a table. You keep scrolling down, there's world population milestones. There's global demographics, 10 most popular countries in the world, and so on. We can see most densely populated countries, and there's just tons of tables here, and I would imagine in the future there's going to be more and more tables. So keep that in mind. While this article may change in the future, you should be able to find at least one table on it. And what we're going to do is we're going to show you how the Pandas read HTML works. And essentially what it does is it just grabs all the tables from a page, and then you can go ahead and explore what tables you're interested in. So let's go ahead and do that. What we first need to do is just actually grab the URL that we're looking at. So we're going to say URL is equal to, and then as a string we're going to paste it in. It should start with https:// and then be the rest of the URL there. Okay, so we have our URL, and then what we do is we say pd.read HTML, pass in your URL as a string, and I'm going to say this is tables. Because what read HTML is going to do is it's going to attempt to grab every single table inside of this URL. So it always returns a list. Even if there's just one table, it's going to return a list of one item. You should also keep in mind that sometimes if you're working on a company internet, your firewall may be blocking you from doing this sort of functionality, in which case you'll have to talk to your IT Or as a backup, what you can do is right click on this, and then actually you can either view the page source, which shows you the entire HTML document, then right click and save this as an HTML file and pass the HTML file instead of the URL. So keep that in mind. If you are being blocked by a firewall, there's kind of this slight workaround, which is again, right click, view page source, then right click again, and then save this as wikipedia.html or something like that, and then pass in the file path because it can read a raw HTML file that way. Okay, so you run this, it'll take a little bit of time, but eventually it should reach out, grab that HTML file, and bring it back to you. So if you take a look at the length of tables and run that, it found 26 tables. And essentially, those are the table tags that are in the source code or source HTML file for this Wikipedia article. In fact, if you're viewing the source, you could do Control F here and start looking for the table tag. I'm looking for a here table, and we can see that eventually there's 1 out of 26. So it's looking for all these table tags, and it's going to attempt to make them into a Pandas data frame. So let's take a look at the very first table it found. So if we say table 0, you'll notice that it's kind of this weird table. It says not a number, and then an editor has expressed concern that this article ... So what's actually happening here is if we go back to world population, you'll notice that at the time of me viewing this, there's actually this little note here that an editor has expressed concern on this article, may have a number of irrelevant citations. This is actually formatted as a table with one cell. It looks like there's an image as one cell, and then we have another cell here for this editor has expressed concern. However, we're not really interested in this table. So probably what we're interested in is let's go ahead and try to get the top 10 most populous countries table here. So this one that says 2000, 2015, and 2030. So let's go ahead and take a look at what the next table is. So we'll say tables 1, run that. And if we take a look at this table, it looks like, in fact, it is the top 10 most populous countries. We can see here world population, and then it looks like it was their ranking, the country itself, and then their population year 2000, 2015, and a 2030 estimate. A couple of key things to keep in mind here is that these hyperlinks, such as the citation on 15, are now broken since it's just the raw text. So keep that in mind. We're just looking at text. Pandas isn't going to be able to keep the hyperlinks when it reads it in as a data frame. So something to note here is if we take a look at the original table in world population, it looks like there's this overall world population at the very top, and then we have the actual columns, number, top 10, 2000, 2015. So the way Pandas reads this in, which is quite common when you have kind of a header on a table, is that world population here is the higher level index. So the columns actually have a multi-level index. And you can confirm this by, if we get a new cell here, I can say tables 1, call.columns on this, and you'll see that it's a multi-level index, where the upper level for every single subcolumn is this world population millions UN estimates 15, which is what this is right here. So we don't really actually care too much about this world population millions UN estimates 15 line. Instead, probably what I just want is the ranking, the name of the country, 2000, 2015, and 2030. So let's kind of walk through how I could clean this up. First thing to do is to probably actually assign a variable to this. So we'll say world top 10 or pop, whatever you want to call it, is tables 1. And then we'll say world top 10. And what I'm going to do is if I say grab the column, this world population column, 15, let's go ahead and copy that and paste it in here. If I just grab that higher level column, it returns all the lower index columns, which are the actual columns I want. So what I'll do here is just reassign this world top 10 to those subset columns, because essentially it gets rid of this higher level index. So you run that, we can see now world top 10 has a lot of stuff of what I want. You'll also notice it has this last row connecting to the notes. We take a look back at the Wikipedia article. Looks like there were some notes here on 2030 equals medium variant, as well as China excluding Hong Kong and Macau. So you may want to include those notes, but right now I actually just want the information. So I've decided I'll go ahead and just get rid or drop this particular row. And we already know how to do this. I can just say world top 10 is equal to world top 10. And I'm going to drop row number 11. And since it's a row, I need to specify axis is equal to 0. So often when you're reading in from an HTML file or a URL, you'll have to clean up a data set like this. You'll notice there's also a world total. So maybe we do want this. It's kind of up to you. But you should also notice right now, this ranking is essentially just the index. So let's go ahead and just remove this column that's this number sign or pound sign completely. So we'll say world top 10. We'll say is equal to world top 10. And I'm going to drop that column since it's essentially just the index as far as what I'm concerned. So I'll say world top 10, go ahead and drop this, and it's a column, so I'll say axis equal to 1. And we keep cleaning up this data. So we see world top 10, and I see 0, top 10 most populous countries, 2000, 2015, 2030, and we can see we have these tags here. Maybe I actually don't want these column names, so what I can always do is just say columns is equal to, and then just relabel it to whatever I want. So I can say something like country, 2000, 2015, and then 2030, let's say estimated. So we run that, and that went ahead and reassigned those columns for us. So now I have this really nice looking data frame. And if you want, you can continue on to go ahead and grab the China B cell and just relabel it China and so on. But essentially, this should give you the idea of how once you've read in a Pandas data frame from an HTML file or a URL, you can use everything we've learned about Pandas so far to clean up the data frame to however you see fit. And keep in mind, sometimes you do get lucky and the tables are just read in completely intact. For example, for my particular situation here, I take a look at tables 6 for when I query this Wikipedia article. And in this case, table 6 is pretty much all ready to go. It's rank, country, and this was the population density. So the top 10 by population density, you can see it here. There's not much that you really have to change here. Maybe you can set rank as the index instead. So you could always say set index, rank, run that, and now you have a really nice table here. And luckily with very little work. But realistically, you have to be prepared to clean the data as such. And let's say you're ready to actually save this or export it to an HTML file. All you need to do is grab your data frame. You can do this for any data frame, not just one you read into an HTML file. And then we say to HTML. And we'll just call this sample table.html. And I'm just going to pretend I don't want to save the index here. So we'll say index is equal to false. Run that. And now you should see, if you click File Open, this has saved an HTML file for us. So if you scroll down here, you should eventually see sample table HTML. You click on that, and this is what an HTML table looks like. And you can always add in styling, etc. And what you can always do is just say, right-click here, View Page Source. And if you're dealing with your own website, what you could always do is just copy and paste the link here to HTML, essentially this iframe link, and copy and paste it. As long as your source path is correct, it should be able to read in this HTML file and display the table. So lots of stuff you can do here. Again, this is more for people that are familiar with web development, but hopefully you can see the power of being able to read in from a URL a Pandas data frame and then perform anything you want with it. Okay, so that's it about reading HTML input and then writing to HTML output. As I mentioned, really important to note here that often firewalls or the website itself could block you from reading in that URL file or that URL link. You may need to download the HTML, and even then, there's probably going to be a lot of cleanup you have to do. So there's no guarantee that Pandas is always going to give you a nice result like we had here on table 6, for instance. The one thing to remember is that it's going to try to grab all the tables in that HTML file, and it's up to you to see if you got lucky and it was able to find the table you're looking for somewhere in that list. Okay, thanks everyone, and I'll see you at the next lecture.